Hello, I am Professor Maria LBS Salingay. I will be teaching you today the basic of measurements. Accuracy and precision. These are important factors to consider in uncertainty in measurement. Precision is the data close to the agreed value, while accuracy is the data close to the correct or true value. Where is the correct and true value in the figure? It is the small white circle at the middle of all these circles. Looking at the lowermost left figure, it tells us low precision and low accuracy because the value obtained are far from each other, so low precision, and also far from the true value, so low accuracy. While looking at the figure in the lower right-hand corner, it states low precision but high accuracy. Low precision because the values are far from each other, but high accuracy because it is near the true value. While the figure in the upper left-hand corner, it shows high precision but low accuracy. High precision because the values are close to each other or close to the agreed value, but still far from the true or correct value. And the last figure in the upper right-hand corner, it states high precision and high accuracy because the values are within the white circle, so it's accurate within the true value, and high precision because all the values are close to each other. Now let's go to significant figures and calculations. For addition and subtraction, the final answer should have the same number of decimal places as the measurement with the fewest decimal places. Now in addition of 145.6 meter, which has 1 decimal places, plus 5.67 meters, which is 2 decimal places, plus 43.456 meters, which has 3 decimal places. First, you have to add all these 3 addends, which is equal to 194.726 meters. And the final answer should be rounded off in such a way that it has only 1 decimal places, which is the one with the fewest decimal places in the 3 addends. So the final answer should be 194.7 meters. Another example. 58.879 grams has 3 decimal places subtracted by 3.62 grams, which has 2 decimal places. First, you have to subtract 3.62 from 58.879, and the difference is 55.259 grams. Then you have to round it off to a final answer with 2 decimal places, which is 55.26 grams. For multiplication and division, the final answer should contain the same number of significant figures as the measurement with the fewer significant figures. For example, in calculating for the volume, it has a formula equal to width times length times thickness. What would be the volume with a width of 15.0 meters, with a length of 25.5 meters and a thickness of 4.5 meters? 15.0 m has 3 significant figures, while 25.5 meters has 3 significant figures, and 4.5 meters has 2 significant figures. The product should contain the least number of significant figures, which is 2 significant figures. So multiply all these factors, the product is equal to 1,721.25 meters cubed. Since you have to round it off to only 2 significant figures, the final answer is 1.7 times 10 to the power of 3 meters cubed. Now, in solving for the density, the formula is mass over volume. If the mass is 1.00 times 10 to the power of 2 grams with a volume of 7.53 cm cube, the mass of 1.00 times 10 to the power of 2 has 3 significant figures, while the volume of 7.53 cm cube has 3 significant figures. The mass and the volume both has 3 significant figures, so the final answer or the quotient should have 3 significant figures. So dividing the mass with the volume, we have a density of 13.28021 grams per cm cube, with a final answer of 3 significant figure, which is equal to 13.3 gram cm cube. I prepared some exercises on conversion, significant figures, and scientific notation. We can work on some exercises together, while the rest you can do it on your own. Now for the first exercise, converting 250 milligram to gram. Now, you multiply 250 milligram times 1 gram over 100 milligram. You cancel milligram, you are left with gram in the numerator. So 250 divided by 100, you get 0.25 gram. Now for the second exercise, converting 300 seconds into minutes. Now, 300 seconds times 1 minute over 60 seconds. You cancel seconds, you're left with minute in the numerator. So we have 300 divided by 60 is equal to 5 minutes. Now, for the third exercise, you convert 5,000 gram to kilogram. Multiply 5,000 gram times 1 kilogram over 1,000 grams. You cancel grams, you're left with kilogram. So 5,000 divided by 1,000 is equal to 5 kilograms. Now for the fourth exercise, 7,500 meters, converting it to kilometers, you have 7,500 meters times 1 kilometers over 1,000 meters. You cancel meters, then you are left with 7,500 divided by 1,000. Your final answer is 7.5 kilometers. Now for the fifth exercise, 87 hours 2 seconds. First, you multiply 87 hours times 60 minutes over 1 hour times 60 seconds per minute. You cancel hours, you cancel minutes. You're left only with second in the numerator. So you multiply 87 times 60 and times 60, you get the final product of 313,200 seconds. And since you are multiplying numbers, or you have factors wherein you consider significant figures, so the final answer should only have 2 significant figures. So you round it off and or you write it in scientific notation. So the final answer is 3.1 times 10 to the power of 5 seconds. Let's go to the exercises on scientific notation. For number 1, it is a very small number. It has 7 zeros at the right of the decimal point. So look at the number of significant figures. There are 3. It is 6, 7, 8. So in scientific notation, you have to consider that you need to write one whole number. So the scientific notation should start with 6.78 times 10 to the power of what number? It should be negative because it's very small. So since there are 7 zeros, so it's 7 plus 1, which is on the 6th place because you make it whole number, so it becomes negative 8. So the final answer is 6.78 times 10 to the power of negative 8 kilograms. The third exercise is a huge number. It is 5,650,000,000 meters. To write the scientific notation, again you have to consider only one whole number and the number of significant figures. So, to write the scientific notation, it is 5.65. Again, there are 7 zeros in this exercise, but unlike number 1, this time the 7 zeros are at the left of the decimal point. So it is a big number, so it should be, exponent should be positive. So the scientific notation is 5.65 times 10 to the power of 9 meters. Now we go now to significant figures in meters. For exercise number 1, 176.675 grams plus 565.68 grams plus 43.454 grams. First, you add them together. The final answer is 785.809 grams. Now, you look at the number of decimal places. So the one with the fewest decimal places is 2 after the decimal point. So your final answer should be 785.76 grams. Now, for the second exercise, 898.567 kilogram minus 15.6256 kilogram. So you subtract 15.6256 to 898.567. So your sum is 882.9414 kilogram. Now considering the number of decimal places, so the fewest is 3 decimal places after the decimal point. So your final answer should be 882.941 kilogram. For the second exercise, 898.567 kilograms minus 15.6256 kilogram. And the difference is 882.9414 kilogram. The final answer should have only 3 significant decimal places. So the final answer is 882.941 kilogram. Let's go to the 7th question on exercise B. Find the volume of water tank with the following dimensions. Length, 45.5 meters, that is 3 significant figures. Width, 15.5 meters, that is 3 significant figures. And thickness of 8.5 meters, that is 2 significant figures. The formula on solving for the volume of water tank is length times width times thickness. So meaning, it should be 45.5 meters times 15.5 meters times 8.5 meters. And the product is 5994.625 meters cubed. So round it off, considering only 2 significant figures, so the final answer is 6.0 times 10 to the power of 3 meter cubed. Now for the 8th question on exercise B, find the density of a known liquid with a volume of 10.5 cm cubed, 3 significant figures, and a mass of 125.0 gram, 4 significant figures. To solve for the density of a known liquid is equal to mass over volume. So it is equal to 125.0 gram over 10.5 cm cubed. The density or the quotient is equal to 1.19 gram per cm cube, that is with 3 significant figures. That's all for today. All I can say, in calculation like measurements, you have to be proactive. You have to solve it on your own and learn from it. If you have some comments, feel free to contact me on the following medium of communication.